Hello, let's do the New York Times Hard Sudoku for December 14th, 2024. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I do have two sevens here. This seven helps out. Oh, these both sevens help out. I didn't see that other one. So ultimately that puts a seven right there in that box, only place for it. This six doesn't have a buddy in the band. We do have this six and this six, so you always want to investigate how those might help. Unfortunately here, they don't really help too much. Not enough to mark anything. We have this five as well. This five really doesn't help. This five, not quite enough. Looking down here, I'm seeing we have two eights, so let's just mark that now. Oops, might be helpful. All right, and so we also have the four, and we have this eight as well, but this 8 doesn't do anything. The 4, there's no 4s at all other than right here, which we could take care of right away if we want. But anyway, always good to be on the lookout for geometry as well. Like anything like this shape is always helpful to think about this versus this column. So we need the 4, 7, and 8 in this column. Interestingly, there's a lot of 8s. Look at this 8, this 8, this 8. This 8. So there's 2 places for 8. We also have a 7-8 here and a 7-8 here. And then we have this 7-8 saying not there. So so there's like 3 places for 7-8. I think that tells us that this cell might be I don't know if that's true. I mean it's 3, 6. Yeah, 3, 6, 9, right? It's not 1, 2. It could be 3. It's not 4, 5. Could be 6. It's not 7, 8. It could be 9. That's not super helpful, but this is like so close to doing something. It's a little frustrating that it doesn't, but I'll try to keep that in mind. I'll try to remember that. Might come in handy later. I'm seeing we have 4 5s looking into this center box here. Anytime that you have 4 of a digit looking into a box, that's going to restrict it to one cell. You can place it in that box. So in this case, we place it here. Same place we placed the 7, interestingly. But there's never like super good follow-up when that happens because you already have 5s in the rest of the band and stack. Let's move on to this band. Let's do this band properly. So we do have the 1s. That does place the 1 here. So placing the 5 helped us place the 1, which is nice. Let's follow up on this 1 and put a 1 in one of these 2 cells. We took care of the 5. We have the 8. These 8s look into here, actually putting an 8 in one of these 2 cells. This box, not so lucky. So we did that box. How about the 1, 2, 4, and 5? So took care of 5, took care of the 1s. 2s look in here like this. This is a kind of a what I would call a crossing, where we have this 1, 5 occupying 2 really important spots that otherwise 2 could have been in. So that leaves just these 2 spots for 2, and that's going to point up along with this 2, putting a 2 in one of these 2. Now with the 2 and the 8 corner mark like this overlapping, this tells us that we have a hidden 2-8 pair. So we can actually replace those corner marks with center marks. What this is telling us is we can't fit any other digits in these 2 cells because one of them has to be 2 and the other one has to be 8 in order to fit both of those digits in this box. So what that's done is it's removed some digits from these 2 cells. The easiest way to think about what digits those are in this case is just think about what these 3 digits are, and we can actually mark that. So we have the 1, 2, we need a 3. In fact, I see these 2 3s looking in, so this places the 3. And then we need, I see that, but hold on. We need a 4 and a 9. Not resolved, but that is a 4-9 pair. So 3, 4, and 9 were removed from these 2 cells by getting the hidden 2-8. Well, this 3 looks up, so that's handy. Puts a 3 in one of these 2. Anything else of note? No, really, there's not much else to do with that, unfortunately. We got this 4-9 pair. I want to follow up on this. Let's clear out this 3 here. Trying to think if that means anything. Well, the rest of this row is down to 4, 6, 9. This can't be 4. Actually, this 4 in general just has to go here because of this 4. And so this is down to 6, 9 as well. 6, 9 pair. I've got a lot of stuff that I can just pencil. So if I see a row column or box down to 3 or fewer, we have this, and this, all down to 3 or fewer. Just pencil them. You're probably going to find something good. So for example, this 1 looks in, so we can just place the 1. And then the remaining 2 digits are a 5 and, what am I missing? 5 and 7. Okay, that's not resolved, but we do have this 5, 7 here, this 5, 7, and this 5, 7. So we end up with a hidden 5, 7 pair right here. So this can't be a 4. This is now down to 3. This is down to 4. Okay, I can't do them all at once. Let's do this one. We need a 2, 4, 9. The 2 4s here tell us the 4 ends up there. Let's follow up on the 4s. We've kind of got a stack of things to follow up on. Ooh, I didn't notice that 4. So the 4 ends up placed here. And so this is 2, 9. Not resolved. Okay, so that took care of that, I think. There's going to be a lot of just different things happening here. We have these 3 digits. We have the 1, 2. We need a 3, 7, 8. That's not 7. That's not 8. Okay. Okay, nothing immediate to do with that. And then we had these 3 digits. 1, 2. We have 3, 4, and 9. Well, I'm seeing this can't be 4, so the 4 ends up in one of these 2. So this is 3, 9. I guess these are just 3, 4, 9. Oh, these can't be the 3. I didn't notice that. Not noticing a lot of things. So the 3 gets placed there. That places our 8. Does that does it for the 8. I mean, we can just see these 2 8s look down. These 2 8s look in. So again, 4 looking into a box, you can place it. That also places our 4. Now this is down to 3 digits. I need a 1, 2, and 9. Oh, well, this 9 will help. So that places the 9 here, giving us the 6 and 9. This 2 tells us that's 2, that's 1. This row finishes with a 6. This row, or box if you prefer, finishes with a 2. Either way. Wow, okay. I mean, this column is finished. We get a 1. That gives us this 1. I mean, this puzzle's done. There wasn't much to it, was there? We placed the 4 and the 8. We haven't placed the 7 yet. Interesting. Okay, so what's kind of... Is there low-hanging fruit still, or do I go back to scanning? I mean, this band's done. I just got so many digits, I don't know what to scan. So we're going to come back up here. We're just going to look at every digit again. We'll look at the blue digits. We have the 4s, the 1s. Okay, so these 2 1s look in here. This one looks up. So that places our 1 and our 3. That does give us this column that we can pencil. So we have the 1, 2, 3, 4. We need 5, 7, 9. Neither of these can be 5. So the 5 gets placed down here. That's our 7. And this is a 7, 9 pair. And that leaves a pair here. It is a 2, 6 pair. This 6 tells us the order. That's 2, that's 6. Okay. Probably just thinking about this row will help. We need a 3, 4, 7, 9. 3, 4, 7, 9. Well, these can't be 7. These are 3, 4, 9. That actually didn't help too much, did it? Okay. This is a pair. There's been a lot of pair scanning here. I need 5, 9. Too late. All right. I'm going to do this column as well, which is down to 4. We have 1, 2. We need 3, 5, 7, 9. Interesting. We have the even digits in 1. 3, 5, 7, 9. Well, the 7 can't go in either of these. So these are 3, 5, 9. That sounds familiar. We have this is something you're welcome to use. I don't use it in my solves. It's something called uniqueness. Well, in general, this is what's called a uniqueness technique. There's a bunch of them. Some of them are actually very interesting and fun to use, but I avoid using uniqueness techniques because they add an extra assumption to the game, which is that there is only one solution. We know there's only going to be one solution because we know that the New York Times ones are logically solvable. There are actually Sudoku books out there that have Sudokus with multiple solutions. I would not recommend buying books like that because you cannot logically solve them. At some point, you're going to have to guess. But we know that there's only one solution. And if we add that assumption, then what we can say is that one of these must be a 3. Because if we omit the 3 from here, we end up with these 5, 9 pairs. This is called a unique rectangle. UR for short. And this can't happen in a puzzle that has, oops, sorry, I didn't mean to press that. This can't happen in a puzzle that has exactly one solution. There's going to be at least two solutions. In fact, there's going to be an even number of solutions to this puzzle, because we could complete it with 5s here and 9s here, or we could complete it with 9s here and 5s here, and nothing else would get interfered with. Both of those would perfectly work in our solution because of this being in. Now, you got to be careful with your unique rectangles. You can only find them when they're in exactly 2 rows, 2 columns, and 2 boxes. If it's across 4 boxes, if it's across, often people will find ones that are this, right? I mean, this isn't one, right? But this is not a unique rectangle because it's in 4 boxes. Something like this pattern could be, but this pattern cannot be because it's in 4 boxes. So 2 rows, 2 columns, 2 boxes in total. Then you can have that unique rectangle, and one of these being 3 would give us that this is 3, and that would help considerably. But I am not going to use that because I like to do a logical solve that proves that the one solution I came to is the only solution, rather than assuming that there was only one solution in the first place. All right, 2, 6, 9 here. This 2, 6 tells us this is 9. That's our 2, that's our 9. These cannot be 9s. And so that's a 7. That's a 5, that's a 3, that's a 7. And there we go. We get our 3, 9 pair there. So we knew that one of these had to be 3. And that has just been proven. That's 8 and 2, that's 7 and 9. That's 4 and 9, that's 3 and 4. I figured I had time to explain that, and it came up. Really wasn't necessary in this case. We've got the 8 here. We've got the 5. Oops. Oh, good thing. I was like, oh no, did I break it? No, I just misscanned. We need a 2. All right. Let's just think about what this box needs. It needs a 3, just down here. We need a 6 and an 8. 3, 6, 8. Can I? Oh yeah, the 3 and the 8 places the 6. This row finishes with a 2. This 8 tells us that's 8, that's 3. We get the 9 and 3. We get the 5 and 9. Over here we have 5 and 6 to place, and we're done. Right. Obviously, would have been faster if I hadn't sat there explaining our unique rectangle. But the only time in our final solution you can get a pattern like that is if one of them is given. So let me find one. It's always very easy to find them. They happen all the time, and that's why you need givens. The givens disrupt those patterns. All right, so I found a few examples, and given them different colors. So for example, here we've got the 4, 7 and the 4, 7. It's 2 rows, 2 boxes, 2 columns. In the orange, we have the 1, 6s, and in the red, we have the 3, 5s. So for example, for these 3, 5s, notice for all of these, there is at least one given to disambiguate it. Otherwise, there would be more than one solution. So what we know for sure is this 7 and this 5 definitely were required. If the solution was going to be this solution, then one of these greens, one of these reds, and one of these oranges must be given, at least one each. It doesn't necessarily mean that will make it unique, but it's a requirement. It's a necessary condition on having a unique puzzle is to give at least one of each of those. And that technique was actually used, this very technique with unique rectangles and a few other identified patterns. That was used to prove conclusively through computer brute force that 17 givens was the minimum necessary givens to make a puzzle unique. 16 would not be enough, because with 16 givens, you cannot cover every way. You cannot cover every single one of the unique patterns that exist in the grid. And they went through every single possible Sudoku grid that are essentially unique and proved it that way. So we already knew that there were 17 given puzzles. We already knew that existed. So that was our known minimum, or that was the known maximum that we would need. That's not a really good way to put it. The maximum value that the minimum could be. But then this method proved that 16 wasn't enough to cover every grid. So anyway, I didn't explain that very well, but hopefully that makes some amount of sense that we know that one of these needs to be given. We know that one of these needs to be given. We know one of these needs to be given. And if you find all the patterns in every single possible Sudoku solution, you can then prove that 17 givens is the minimum number of givens to make a puzzle unique. Now, in my experience, 17 given puzzles generally, on average, are very easy puzzles. And so the number of givens is not necessarily, is not at all correlated with difficulty until you start getting into a huge number of givens where it's impossible to make anything but a trivial puzzle. But even at 40 givens, there are still very difficult puzzles. So, but yeah, 17 is the minimum because otherwise you cannot have exactly one solution. So there we go. Nice little lecture there at the end. Hope that was helpful or interesting. And I hope you enjoyed this. Let me know how you did. And if you did enjoy this, why not leave a like, subscribe, and a kind comment below.